Hello class. In this short video tutorial, we will talk about voltage regulators. In the last class, we talked about how a half-wave and full-wave rectifiers along with filters can be used in order to convert an AC signal into a DC signal. The final stage of that power supply is going to be a voltage regulator. As we saw from the lab that the output of the filter is not going to be a completely constant DC signal, because we want the DC output to be as constant as possible of the power supply. But after passing through the filter, the output of the filter consists of ripples. The output of the filter is not completely constant signal as a DC signal. So the final stage of the power supply is going to be the voltage regulators. A regulator, the name itself suggests that it regulates, it will maintain a constant output voltage. So it will try to maintain, again, remember, no circuit is ideal in nature or perfect. So it will try to maintain the output voltage despite the changes in the input voltage, load current, or the temperature. So usually a voltage regulator is going to be a combination of a large capacitor filter, which we use in the half-wave and full-wave rectifiers. There is going to be another capacitors in order to improve the transient response of the system. So most of the regulators are readily available in ICs such as 7805, 7905. So for example, if I take 7805, the last two digits will indicate the voltage this IC is going to regulate. So this one is going to be a 5 volts regulator. 78 indicates it's a positive voltage. So this 7805 regulator is a positive 5 volts regulator. So for example, if I take 7905, again the last two digits, that's the 5 volts. The first two digits indicates that's a negative voltage. So 7905 is a negative 5 volts regulator. Some regulator in general will also consist of short circuit protection and thermal shutdown capability as well. If I have this 7805, I'm expecting the output of the 7805 regulator to be 5 volts as possible, even though the signals from the input side fluctuates. So for example, if I have 6 volts, I'm expecting to be at exactly 5 volts. Even it's 7 volts, I'm expecting again to be at 5 volts. But in practical applications, this won't occur. So for example, if you go like 6 volts, you're possibly expecting instead of 5 volts, you're expecting like 5.001, something like that. If you are regulating from 7 volts to 5 volts, you are expecting like 5.06, something like that. So it's going to be increased, but it will try to maintain the output voltage as constant as possible. But in practical applications, you will not see that output voltage is going to be exactly 5 volts. So that input side variations, for example, here the input signal variations, the signal varies at the input side, then if the regulator is regulating, it is called as a line regulation. So line regulation is basically how much change occurs in the output voltage for a given change. So change in the output voltage for a given change in the input voltage. So that is called as a line regulation. So for example, if I consider a 7805 voltage regulator, let's say I'm applying 6 volts. Again, I'm expecting the output to be 5 volts. Again, as I said, in the practical, you're not going to see 5 volts. So let's say you're looking at 5.1 volt. If I increase this voltage, for example, something happened, the input voltage rises. I'm expected the output should be at 5 volts, but it's not going to stay at 5 volts, it's going to rise. But again, it's try to maintain as close as possible to that 5 volts. So here we have an input voltage, the change in input voltage. So that delta is for change. So change in input voltage is 1 volt, and change in output voltage, again, the delta V out is 0.1 volts. So you went 5.1 to 5.2, so there is a change in 0.1 volts. So the line regulation is nothing but change in output voltage over change in input voltage. If you're looking for a percentages, you multiply it by 100. So in this case, the percentage of line regulation, change in output voltage is 0.1 volt, change in input voltage times 100%. So that's basically tells you there is a 10% of line regulation in this particular system. So that's what a line regulation means. Line regulation will talk about the output change with respect to an input change voltage. On the other hand, we have a load regulation. So this load regulation will talk about with respect to the load point of view. So how much change occurs in the output voltage over a certain range of load current values. So it is going to be defined as voltage at no load condition minus FL. FL stands for full load. So no load minus full load over the full load times 100%. So line regulation will talk about the input point of view. If the input changes, how much out percentage of the output changes. And the load regulation will talk about the load point of view. For example, if you consider a motor or a light, so that's from the load point of view. It will talk about how much output voltage will change over the various ranges of the loads. So in general, practical DC power supplies will require a voltage regulator at a final stage so that the input fluctuations, remember that the output of the filter is not smooth signal, it consists of a certain ripples. So the job of this regulator is to reduce those ripples as much as it can. Again, the voltage regulator will not completely eliminate any fluctuations at the input side. It will only try to reduce those fluctuations. So that will complete that whole power supply. So we started with a transformer, we stepped down the voltage, passed through a rectifier, and then the rectified signal, whether it's a half wave or a full wave, it will pass through a filter stage, and then the output signal of the filter will pass through this voltage regulator stage to reduce any ripples. Thanks for watching. That will conclude this lecture.